Kinematic problems you will see quite a few of in your days in IB physics. And when you see them, you should be excited because they can be easy once you get the process of how to solve them down. So here is the first kinematic problem I want you to try and solve. Now pause this, take a good amount of time to solve it, do some graphs and do some calculations, and then move on to the next part where I explain how it is all done. Make sure you think before you look at the next part. Did you draw a picture of the situation? If you're struggling and you didn't, then draw one now. It will help. Show you mine. Boom. Here I've got Kavita throwing it downwards, and here I've got May, and hers goes up and then goes down. The most important thing I did over here is that I defined what is positive and what is negative. I defined up as positive and down is negative. You could have done either, but it's important that you define those. Now let's solve the question 1 about how high the rock goes above May's head. We're going to call this displacement S, because that's what the IB always uses. Now let's write down what we know. We know that the initial velocity of the rock, right when she throws it, is going to be plus 14 meters per second. We know the acceleration of all projectiles is going to be 10, and ours is going to be negative meters per second squared. I rounded that. And I also know that the top of its height, its final velocity, is going to be 0 because it has to stop and turn around. Now I think what equation, and I choose from the 4 equations of motion in my IB data booklet, and I find that if I use this equation, it's going to work out nicely. And here it is, the work. Hopefully you got the same thing. Notice what I did with the signs, and it works out to a positive height because up is positive. For question 2, we're asking how fast does each rock plow into the ground. Now you want to pick your equation again, and I'm going to use this one again. It works out nice because I don't actually know very much about the time yet, and this doesn't have time in it. Boom, here's the work, and you'll notice that when I plugged in these numbers, I had to do a lot of stuff with negative signs, which maybe means picking down as negative was not the best idea, but I'm going to go with it. And notice what happens with these negative signs. I end up on Kavita's side having a negative velocity at first, but it's squared, so it doesn't matter. And then I end up getting a plus or minus 21 meters per second. Clearly it must be minus because the ball is clearly going to be going down at that point. Now with May, you notice the only difference in this equation is that you put in a positive 14 here, but it gets squared anyway, so it doesn't matter, so you get the exact same answer. The rocks hit the ground at the same time. That's a common thing that comes up in kinematics and projectiles, is that if you throw a ball upwards at, let's say, 14, it's going to stop and come back down. When it's right even with you, it's going negative 14, which would be the exact same thing that happened with Kavita throwing it down. So the only difference in what happens is they hit with the same speed, but this one from May just takes a lot longer in time. Clearly, Kavita's rock will hit the ground before May's because of that extra flight distance. The question is how much earlier. Now, so you're going to need to deal with an equation with time in it, and you've got a couple choices. I wrote those down here. You do not, in this case, want to deal with this one because if you put a displacement there that is not 0, which you'll have to do, you're going to have to use the quadratic equation and avoid the quadratic equation at all costs if you can. It takes a lot of time, and there's better ways to do it. So I recommend this one. Try that now for both of them. Here is the work and the answers, and notice that I'm using the velocities I got from the last problem, which is a negative 21 meters per second. For Kavita, you have to have an initial velocity that's also negative. The negative signs do all cancel out, and they have to give me a positive time. You should never ever get negative time answers, meaning that something went backwards in time. It would make sense. It would be detrimental to all of us. May, I use the exact same equation, except I put a positive in here for her initial velocity because she threw it upwards. And I get a much higher time of 3.5 seconds. And then I took the difference between them, and I got that 2.8 seconds as how much earlier Kavita's rock hits the ground before May's. For the displacement, I always start out by drawing your axes, and you want to think about where the rock is going to start and where it's going to finish. Let's start with May's rock first. We're going to call where she and Kavita are standing as the origin. So May's rock is going to start at the origin. The end of time, it's going to end up in the negative down here. So if we're going to make this the impact time, it's going to end up down here somewhere in the negative area. And we know that it has to start going upwards. And we know that it's, well, hopefully you've heard that all projectiles have a parabolic function. So we know that it's going to go up in a parabola shape, and it's going to come down. This is where it goes back zipping past May on the way down there. Now, we'll change colors, and we'll talk about what's happening for Kavita. Hers starts at the origin as well, at that height on the origin, and it never goes into the positive. It only goes into the negative, and so it's going to have the same initial velocity or slope that May's does. So it goes whoop. Now you may not think of this as a parabola, but it is a part of a parabola, same shape. For velocity, again, start with your axes, and again, we'll start with May's rock, because it's the slightly more complex one. And you want to think about what velocity does the rock start at, and where does it finish at. The rock is going to start with a positive velocity for May, because she throws it up. It's going to end with a negative velocity, and an even larger negative velocity, because on the way down, when it gets even with her, it matches the upwards velocity at negative 14, and then it's going to get crazy faster to that negative 21. So it's going to end down this negative. The slope of this tells you the acceleration. Now you should know the acceleration of a projectile is always negative 9.8 or about 10 meters per second squared. So it has a constant slope, which means it's a straight line. So that has to mean that we end up with something that looks like this for May's rock. Starts with positive. Here's the turnaround point at 0. Now it's matched the upward speed with its downward, and then it continues to go faster. Now we change colors, and we talk about Kavita's. At the same time, she throws her rock, but not with 0. She's going to start with the negative counterpart to May's. So hers starts at negative 14, and it must have the same acceleration, so it has to have the same slope, and so it's going to end up at the same slope going down and matching. This is supposed to be at the same height. It ends up with the same impact speed as May's. That's it.